Welcome to the Flux Dev Meeting, April 8th.
Hi everyone. So we are back from KubeCon. I'm still sick. Matheus is not. Kingdom took a break. So here we are. Um, some news from KubeCon. We have published all the FluxCon talks, the recordings, and you can find them at fluxcd.io/KubeCon. The talks from the main tracks are not yet online on YouTube, but FluxCon is. So if you want to check out the talks, you can find them. There is a YouTube playlist, and we list them all on our website. Um, so at FluxCon, we have launched the official FluxCD AI skills. You can find those on the FluxCD organization. I've pinned them to the org page. The repo is called agent minus skills. And if you have time to play with it, please give us feedback how it went. There are three skills in there. Two of those are made for static analysis, and one is built on top of the Flux MCP. So we have a GitOps knowledge skill. This one is there are two goals with this one. One is for you to be able to chat with an agent around, Flux best practices, and how to organize your repos, all the things. And it also, another goal is for an agent to be able to generate valid and up-to-date Flux definitions for you. Basically, you can tell it, hey, I have this app, I want to deploy it through Helm. Here is the Helm chart. Please give me the Flux manifest for it. Manifest, and it will give you the right constructs. It will generate a valid YAML and so on. So this is the knowledge skill. The second one that works on files and repos is called GitOps repo audit. And what this skill does, you can spin off a sub-agent. We also ship you dedicated sub-agents for Claude, for Codex, Hero, CLI, Copilot, and so on. And the sub-agent will clone your repo and do a static analysis on top of it. So it will look for things like how is your repo organized? Does it match is one of the um, let's say predefined architectures, like maybe you have a monorepo and the source of everything is Git, and you have different clusters defining there. And once it identifies the type of repo, then it does a deep dive into it. It will look for it will validate all the YAMLs in there. It will build all your customized overlays. It will look for, have you implemented best practices? If it finds, let's say, fields that are missing, or fields with values that will cause disruption to Flux. I don't know, you've set up customization interval to 30 seconds or something like that. This kind of stuff will basically DDoS your Kubernetes API, and the agent will be able to detect that and also suggest changes. It will also scan for secrets, things like, you forgot to use SOPs, or you have like secrets in plain text, or you have hard-coded some password in a Flux Helm release. And he's quite good at finding those. When we develop the skills, I run them on a couple of hundreds repos that I found on GitHub. And it actually find a lot of not only issues but actual secrets that people left in there, which is not great. Other things that it will do, it can also it also understands when you have these separation of concerns. If you looked at the white papers that we published under control plane with the D1 and D2, the architectural guides, we encourage people to have a fleet repo where you keep all your cluster definitions and where you onboard tenants, an infra repo where you have all your cluster components, and app repos that maybe match your organizational structure. Maybe each dev team has its own repo, or you have, I don't know, an app made of many microservices, and in this case, the repo is the actual app with all these definitions. So we have published some documentation in the skills repo how you can um, make the main agent spin off sub agents, one for each repo. They will do the deep dive in each repo. They will analyze each one, but then it will feed these reports to the main agent, which will understand, okay, all these repos are based, this is the whole desired state of the cluster fleet. And it will be able to correlate and understand how the reports are linked together and come up with a good, analysis and suggestion around how to how to improve the things, how to refactor. It can also help you move from, let's say, Flux Bootstrap to the Flux operator. How it can move from Git repos to Gitless to CI repos and so on. And the third skill that we have in our catalog is the GitOps cluster debug. This skill is built on top of the Flux MCP server. So you would have to have the MCP connected to the agent. And the skill will help the agent run the diagnosis and troubleshooting and root cause analysis for, let's say, a failed ham release or some widespread, failure where customizations are stuck, which depends on and so on. You don't necessarily need this skill. With high reasoning LLMs like the ones in Codex and Cloud Code, they should be able to figure out, the way how to use the MCP tools to do a proper debugging. The role of the skill is here most on reducing the amount of tokens, reducing the amount of steps and the number of tools a model should call to determine the right path to debug something. So it also helps these, LLMs that have reasoning built in and they are quite knowledgeable of Flux. But when you use non-reasoning models or models with thinking set to low, the cheap ones, here you'll see a major gain in terms of troubleshooting, because we have in the skill this kind of workflow with a step by step, and we give the agent a clear plan on how to act upon an incident. Even if you use these cheaper models, from our experimentation, the result is quite the same. So, for example, you can use, I don't know, Sonnet instead of Opus, and the result of a root cause analysis is like 99% the same, which is a major gain because you can do this stuff with spending less tokens and less money on it. So yeah, these are the things that we've launched at FluxCon. Other other things is that for the Flux project, we have released a series of patches that are stabilizing Flux 2.8. We found some Helm issues that we fixed in Flux. They are not yet merged in Helm upstream. So now we are waiting for the Helm team to um, do their own release. But these issues were quite serious, so we made a temporary fork under the Flux organization for the Helm project. We fixed it there, and some of these fixes are already in the latest Flux release. We also found some issues with cancellation of health checks or customized controller where customization could get stuck in some for in some conditions where you do one commit after the other, and we found the solution how to fix this, and this has been released yesterday is 2.8.5. So please upgrade to the latest patch version if you have enabled um, health check cancellation in customized controller. This should really help. What other things? Mateus, do you have anything to say about what you are working on? What's the plan next?
Cool. So maybe quick update about Helm. Uh, in the last few dev meetings um, we talked a lot about the bugs that we have open. In particular, in the last meeting, we gave a very thorough overview of which bugs we have at the moment. So basically, today's update is no update. Like since last week, Helm did not review any of our PRs. Nothing happened. I went to their dev meeting on Thursday. Was able to talk about it with them. It was like basically the main topic of the meeting, but no activity since then. So keep going to their meeting and seeing if they can merge our PRs. But basically, um, we the to summarize the current situation is Flux has a Helm fork at the moment where we shipped a PR, and we are a bit afraid of doing this again without Helm merging those PRs upstream. So we're gonna try to keep a buffer of one PR ahead of Helm in Flux so that we don't trap ourselves into a Helm fork that we need to maintain forever or anything like that. Uh, yep. Um, Talking about Helm, a new issue just popped uh 2 hours ago in Helm controller about force. So force is a thing of client-side apply and cannot be used together with server-side apply. Uh, and I think from what I understand of this issue, this is actually can be considered a bug on our side. So they have upgrade force true in their Helm release. Um, if since the default now is Helm 4 default, which is server-side apply, when you install a Helm release, it will use server-side apply. And when you upgrade it, you're gonna hit a problem because you have force true in your upgrade config. Wondering, however, how we should solve this because let's say we uh, could ignore force true when server-side apply is set, for example. But then we are uh s- we're like the config is wrong, right? If your Helm release is using server-side apply and it has upgrade force through, the configuration is incorrect. That force through is being ignored, and that's not nice. However, I can see how this is like this person probably hit like it's like imagine you have a Helm release with force through, you install it, it installs fine, then an upgrade it explodes because it has force through. That's not nice either, right? So what do you think?
They're different things, right? Why would this conflict?
Helm SDK sees, oh, you're saying force conflict, uh, but you're also saying force. You cannot set both things.
Why? They are unrelated completely.
Uh, Good question. Maybe a bug in Helm then? Like but they have like explicit checks for not being able to use both things at the same time in their code. So,
So force through is for replacing things that are
mhm,
failing.
right.
Forcing the conflicts of managed fields is completely an unrelated stuff. And yes, you can't not resolve the conflict because otherwise server-side apply will always fail. But these have nothing to do one with each other. They are very different things.
Yeah, makes sense to me. But trying to find here the error. Yeah, just found here. Sent the link on the chat. Helm explicitly denies allowing two force booleans to be set. Maybe this is wrong from their side. Like, I wonder why they did this. This is the exact error that the Flux user reported.
Yeah, so for server-side apply, they set it to the patch option, force conflict, which this one is about managed fields. Yeah, so basically they don't have recreate for server-side apply. If you change the labels, the label selector of something with server-side apply is impossible to recreate the deployment. So they decided to basically drop this feature because SSA will never do a delete. We in Flux, in our SSA package, we have special handling of force. We detect there is a immutable field problem. and we delete and create that object. They don't have any of this logic.
If you have like spec.force true, right?
Yes, or the annotation.
So I haven't checked how they do this. Like I assume that prior to server-side apply, this force feature is also something like in Helm. It's also something they do themselves, right? Like they forcefully recreate an object. This is what force is for. Force replace.
Could be right. That's why it's called replace. I don't know.
So
Maybe
could
it doesn't do anything. No.
yeah. Okay. So I guess from what we should do is check what this force replace feature did before Helm 4 and see how it can be carried through for server-side apply and maybe raise this as a bug.
I mean, from their code is intentional that they don't want to recreate stuff with server-side apply. So you need to if you change the label selectors, you need to go in there and do kubectl delete.
But could this be implemented in Helm 4 if they were convinced? Without a
Yeah, we need
breaking
to
change
convince
at
them
this point?
of too many things.
Yeah, the most tiresome job, convincing them, depending on something like having a huge dependency on something you do not control.
Yeah, so force conflict is about managed field resolutions. Has nothing to do with immutable errors and so on. It's
Mhm.
about transferring ownership between managers, and I don't know if a field was you apply something with kubectl, server-side apply fails. And that's how they solve it here by setting this force thing, which is has nothing to do with anything. So yeah, you need to test like this. Have pod info with some config with some label selectors. See what Helm v3 used to do. The old Helm controller, when you change the selectors and you have force true, if it recreates the deployment, do the same with server-side apply. It will, judging by their code, it will fail and never recreate. And if that's true, yes, we need to just ignore force in Helm controller when
That sounds like
server-side
a
apply
bad
is
regression
enabled.
in Helm, right? Like, what's best for Flux users and Helm users? For them to fix this, right? Like, if they're
Yeah, but
unrelated
it's
things.
they cannot use controller runtime anymore. They have to build their own stuff because the controller runtime uh, patcher and what they currently how they build their own server-side apply thing. That one, the patch they only use patch everywhere, right? And patch will never delete stuff. There is no way of recreating cannot be done through a patch. You need to issue a delete. You need to wait for it. You need case status in there, all the things that we build in Flux SSA.
Got it. Yeah.
But first of
Well,
all, we need to see if this is a real regression of or not. If Helm controller, the old version, you set force, you change label selectors, would that force actually recreate? Right? If it will do a recreate, if you delete the deployment, reapply it, and it succeeds, then it can be considered that this is a regression. The Helm maintainer may say, we don't care about this use case. It's okay. Server-side apply never does not support force recreate. Because if you see, they also changed the name of the field. It's no longer force recreate, it's force conflicts. And
Yeah.
conflicts is around manage fields, recreate is around recreate. Totally different concept.
Yeah.
So by reading the code, it feels like they have intentionally dropped the possibility of
Forcefully
recreating
recreating.
stuff. Yeah, not being able to change stuff like label selectors or I don't know, the job spec. There are so many immutable fields in Kubernetes.
Right.
Um, the
Yeah, so just one question, like this forcefully recreating an object is not something the API server does, controller runtime does, client code does. None of these things do the forceful recreation, right? It's always our code, like it's the tools applying the objects that have to do it, right?
Yeah, kubectl has a force.
kubectl, so kubectl, Flux, Helm 3, all of these had logic for deleting an object and creating it again, right?
kubectl and Flux for sure. I can't be sure about
Mm.
Helm.
Okay.
So that's why I'm saying um, before jumping on conclusion, we should actually see if setting force in a Helm release recreates the deployment or not. If it doesn't, then there is no breaking change. We just have to ignore the field. If it does, we should still ignore the field because this is what Helm 4.1 wants. Tell that and create an issue for them. Hey, if I'm changing immutable objects now with server-side apply, there is no option in the SDK to recreate the objects.
Yeah. Yeah, if everything happens as we are predicting, I guess the conclusion is this is a regression, right? Like I was able to forcefully recreate objects in Helm 3. I'm not able to do that in Helm 4 with server side apply. Should be possible, right?
Yep.
Cool. Okay, I'll take care of this. I guess enough for Helm for now. Let's talk about happy things. Uh, I wanted to talk a bit about our Spiffy Inspire integration. So
Okay.
yeah. Um, so last week on Thursday actually went to two meetings. I went to Helm and Lee went to Spiffy. Um, Also I was able to join at the end in Spiffy a little bit. And I guess there's two things to talk about. One is uh the broker API that Spiffy is introducing. That's what the meeting was about. And we were able to um, communicate with them our main use case, which is issuing Spiffy SVIDs for Kubernetes objects, right? So we just reiterated with them on this. They also asked how we can, for example, how can Spire test that the broker that is issuing a cred for an object is actually entitled to do that, has a permission to do that. And then Lee and I suggested self-subject access review. So I suggested specifically using the impersonate verb. So that's an actual verb, right? Like when like Flux, for example, is impersonating a service account, it's literally required to have like the customized controller service account needs to impersonate permission on users because the service account is a username. So that's the permission that customized controller needs to be able to impersonate the service account. And I suggested, yeah, like make check if the like if you're able to identify the Flux pod, which service account it has, and if you reach that service account, you want to test it, if it can act on behalf of objects, then I guess the best thing you can do is um, check if you can impersonate that object. That's a bit unprecedented in Kubernetes because even though the impersonate verb exists and is used for users and groups, in this case, the resource you're impersonating is a resource, right? So you would do the self-subject access review for impersonate on an OCI repo. Um, so this would be sort of a Spire only behavior, right? Like a beefy Spire only behavior of checking impersonate in objects. But that's probably the best they can do if they want to like the problem they want to solve is okay, how can I be sure that this broker can actually is actually allowed to have a credential for this object, right? So let's see what they do with this suggestion. Um, I guess this is not going to be a big problem. They're going to do something. They're going to support anyway. Like what at the end of the day, what we want is for Flux to be able to talk to Spire and say, I want a credential for this object. Give it to me. And that's it. So yeah, on this side, things are like pretty straightforward. No big blockers. But on the other thing I wanted to talk about which until recently was a big blocker, but I believe it is no longer a big blocker after a feature we're about to ship in the Terraform module we're making for bootstrapping Flux Operator is having uh, bootstrapping a cluster with Flux Operator, Inspire, and making it work, like making the Flux pods mount the CSI driver that Spire has for talking to the APIs, which needs a Unix socket, right? So for a Unix socket, it's either CSI driver or host path volume, which what we want to avoid because we have PSA, PSS annotations in the Flux system namespace. So to avoid that and use the CSI driver, basically the only way is you install Spire in the cluster before Flux. There is no other way, right? So what I did and successfully tested in this Terraform module for bootstrapping Flux Operator is do that. Like essentially, it offers an API that allows you to install a Helm chart before Flux, and it works. It the CSI driver gets into the cluster. The Flux pods, the Flux instance has a patch to add the CSI driver as a volume in the Flux pods. And it works. The pods come up. They don't get blocked in container creating state when the CSI driver does not exist in the cluster. And I guess that's gonna be our answer. Like that's gonna be uh that's how we can integrate with PC Inspire, basically. Like um there's only one way, Unix socket, CSI driver, and it has to be in the cluster before Flux. So we're solving this in the Terraform module for Flux Operator. And if you're not in Flux Operator, I guess you know what you have to do. It's gonna be a bit complicated, but you know what you have to do. You have to install Spire before Flux. That's it.
How
Like,
the CSI driver avoids PSP or what?
I don't know how it works. Like, I just know that the CSI driver is what allows you to get the access to the Unix socket without requiring a host path volume. That's how I know.
Wow. But if the driver is only installed, there is no socket, right? So Flux will do what? It will start, it will try to read from the volume will have nothing and crash, or what will happen?
Uh, right. You're basically asking me do a more thorough test, a more end-to-end test. That's what you're asking. I only went as far as telling the Flux instance to add the volume to the Flux pods and seeing the pods come up healthy. That's all I did. But like the moment they at that point there's no Flux, there's no Beefy Spire integration in the code yet, right? So uh Flux is not trying to talk to the socket at this point. And I can actually because at the end of the day, how this is going to work is we're gonna need two APIs from PV Spire. Workload API and broker API. Broker API is for a broker to get credentials for other things, like Kubernetes objects. Workload API is an API for the workload to get credentials for itself. To use Broker API, you need Workload API because Broker API is going to be exposed over TCP. And for you to attest yourself as a broker to Spire through TCP, you need a strong attestation. That strong attestation is going to come from you talking to the Workload API. You're going to get an X509 SVID, so assert. You're going to use that for MTLS with over TCP to consume the broker API. And this means I can already test the workload API. We don't have the broker API yet, but um, since the CSI driver in the socket is for the workload API and that already exists, I can do this test and report back in the next meeting. So I can hack the like how Flux is going to call this API and test it. I'll do it and see what happens at this point with the Bootstrap module.
Yeah, so I see the Spiffy driver is not PSP compliant. Basically, they run a daemon set on all the nodes. So you are not going to get access to any socket. It's the daemon set that does it for you. And the only thing that it does, it will give you the cert in the volume.
So we don't call we like don't call the API directly. We just look at the path where the cert will already be.
Yeah, you'll have var run /var/run says secrets spiffy.io. That's the mount. And in there, it will deliver in a transparent way SVIDs, 509
Nice,
certs, key pairs. Right.
nice.
You'll
So
just
basically,
scan the path, find certificate, and whatever you need to do afterwards with it, it's
It's going to
I'm
work.
guessing the same as any workload identity stuff, right? Because now you have the cert to work with.
Yeah, yeah. Yeah, cool. I just loaded and I opened the connection with the broker API using it via MTLS.
Yeah, or I don't know, Cert Manager, I see does. Cert Manager also has its own CSI driver Spiffy.
Yeah. Yeah, maybe we can let the user choose the path to the cert so they can choose either the Spiffy path or the cert manager path.
Yeah,
But
so
since
this
what
one for Cert Manager is definitely just giving you a cert that you can use then to issue certificate request.
Yeah. I mean, I would say like what we want to consume at the end of the day is this beefy broker API. And I'm not sure cert manager, beefy CSI driver.
No, this is that another thing. Like you'll use that to issue certs based on this CA, and those certs will be accepted by other things uh, that trust cert manager certs.
Hmm. Right. Yeah, so maybe here this is like another feature entirely that we would be talking about, right? Like so.
Yeah, no, not related. What I'm looking at their docs as an example of what you actually get when you use the driver.
The cert manager
So
part.
yeah, in our case, you get the certificate that should allow you to open a MTLS connection with the broker, and then whatever happens with the broker is the same as what happens with cloud APIs, right? You
Yeah.
exchange the token, you get token signed, then you can impersonate that identity further on.
Yeah.
I mean, that kind of code we shouldn't be changing. That should be the same.
Yeah. One thing I realized is that the cloud APIs, the way we integrate with them right now for object level is that we exchange an OIDC token for a cloud token. We can do the same for Spiffy. Like Spiffy, there's at the moment two types of SVs, right? Uh, OIDC JOT and CERT. We can do like we can do many things actually. We can do what they already do and then exchange an OIDC token from Spiffy for a cloud token. That's one thing we can do. Another thing we can do is no cloud involved, right? The whole point of the RFC, which is vendor agnostic credentials. For example, ZOT and Harbor. Those are gonna consume the OIDC token directly without exchange. And there's also in the clouds, there's also um, X509 support in at least two of the clouds. AWS and Google, they can do the same type of credential exchange that we do today through OIDC. We can we can do the same with X509. Like I connect to AWS with the cert, and it gives me back short-lived creds. So this
Why
is
would we do that?
uh, like uh it's just a different type of credential. At the end of the day, you're getting the cloud credentials and using it for whatever. Just like today, this is called OIDC Federation in Amazon, right? Like you configure, okay, I trust this OIDC provider. If you show me a token for it, I can give you back AWS credentials. There's another feature with a different name that is the same thing, but for X509. It's called IAM roles anywhere. AWS IAM roles anywhere. This feature does the same as OIDC Federation, but X509 instead. So, you know, and like honestly, I just wanna their C has to be focused on the API that we need to support, that we need to structure to support all these use cases, even though we're not implementing all of them at once. Like we don't need to go now and implement X509 Exchange with all the clouds, but I want to be prepared to support this if people ask for, and I can add it to the API without struggle, like without figuring an API that is intuitive and there's no breaking changes and everything. So basically, like it's an overwhelming amount of combinations that are possible, and I want to be prepared for all of them, but only implement a few of them in the first iteration.
Yeah, I don't know. Let's see if someone asks for PC2 cloud integration and then we can consider it. But it's already the OEDC docs and everything are like crazy complex. Adding yet another stuff that no one will use feels wasteful. Um,
Yeah, yeah, exactly. Like I don't want to implement that on the beginning, but I want to whatever API we choose to go with to be able to support this later when people ask, if people ask for it.
yeah.
That's all.
So yeah, for now, let's see if we can make this work with not the three clouds, something else that would support this.
The container registries. Yeah, yeah,
Not from the clouds.
yeah, yeah. Like Zotin Harbor. Yeah, I already tested it. Like this is shipped in Zot, and in Harbor it's shipped in their SaaS.
What about people asked us for other clouds like Oracle and others. Can we just say, oh yeah, now we have Spiffy, you can do it?
Um, my guess is that they're gonna be the same as the three main clouds. Like no cloud. I know no cloud that allows you to present a foreign token and use it for API calls. All the clouds have some exchange handshake. But I can search. Oh, Does Hetzner support OIDC for API calls or Oracle? I can take a look, but I think it's unlikely. Especially Oracle is the most complicated, like is the most strange. I worked with Oracle Cloud a bit. The way they do things is very different. But yeah, I guess like the takeaway here today is Bootstrap is possible.
Cool. Cool. We need to make a stable release of the new Terraform module, and then you should write the blog post on FluxCD how people can use it.
Cool. Just finishing here a few.
Basically, we want to show people how they can migrate to from Flux TF provider, which requires all the interactions with Git. You need to write to Git. You need all that stuff. How you can move from that to the Terraform module of operator, which has only read access to Git, and show people how they can. There are two main advantages, right? You can now couple the Bootstrap with your cluster uh, creation, which is not possible with the provider, or it was not possible before. And people over the years asked for a way to do it, and now it's possible. And the second one would be around how you can get prerequisites deployed in the cluster and those prerequisites like Helm charts for, I don't know, let's say Cilium. And you can then Flux takes the ownership of that particular cluster add-on without resulting into conflicts in your Terraform module. Because that was possible before, right? You will create like a Terraform hand release Cilium, and you would create a hand release definition in the repo. Flux will take over, no issues. But then when you do a Terraform apply, all the stuff breaks, right? Because then Terraform will say, "Oh, what the hell? Someone else is managing it. The version is higher or whatever, right? They need to like do an upgrade for a lower version to roll back, and it's a crazy mess." Um,
Yeah, we
so
use
all
the
of
solution
these,
proposed by Mateus for that, the flip, so that it goes hands off once there's a detected namespace and source controller. It says, I'm not installing Flux anymore. Flux is responsible for what's inside the cluster. And it's hard to understand, but it works.
Yeah.
what do you
We
mean?
had
If the drift is still there in them, right?
Yeah,
So
Terraform no
if
longer
you,
controls those resources. The expectation is that you'll use GitOps to manage them, but there's no control for that.
yeah, but if you run a Terraform plan, the plan will say there is drift, right? Because Flux has taken over, and meanwhile, maybe some release has been upgraded.
Oh, you have to eject the state of those resources for this to work, I think. Yeah.
Exactly. So you need to go in there, mess with the state, and take out from the state the things that you have bootstrap. Now with this model, Terraform module, what we do is we spin up a job, a Kubernetes job in a dedicated namespace that does the initial Helm install. So it's not in the state of Terraform. The Terraform state only tracks secrets like the bootstrap, the git secret, whatever, and the job itself. So it has no knowledge that you actually have Cilium and other stuff in there. It's only Flux that manages it. What we do is like run a Helm install or a kubectl apply only if nothing is already managed by Flux. So it has this like if does not exist logic. Only then we spin off the things because the certainty is if they exist and they have the label Helm toolkit, customized toolkit Flux CD, we shouldn't touch them. Like, okay, they are like fully managed by Flux. And we do this from the job instead of Terraform. It's impossible to do it from Terraform
Yeah, now I remember how we
without causing
avoided
drift.
ejecting the state now because we're using Helm to install Flux operator, but we're only doing that if source controller isn't detected. So there's no drift because we're pulling source controller in
That's
as
exactly what I was doing before. Like,
that's what you showed us how to do. And it took a very
right.
long time to understand why. The LLM didn't like your solution. It tried to turn it into the other thing, and the
Yeah.
other thing broke in the way that Stefan's describing now.
Yeah, like many people didn't like that solution. It worked for us for a while. But yeah, messed up.
But
What
because
we
Terraform isn't creating source controller at all, it's only observing the state, does it exist or not, and using that as the signal, then
yeah.
it doesn't have any conflict and
And
you
you have
don't
to
have to
break
eject the
into two
state.
root Terraform modules where the second one doesn't have state. The one that does the bootstrap. Yeah.
Yeah, we still did it with one Terraform module, but you have to run it twice. But you are going to have to run it twice for another reason unrelated to Flux anyway. So
Right. Yeah, with this new module, like the whole experience is different. Like it's much better now. Yeah.
Yeah,
Uh,
we moved the whole logic to a job, right? And Terraform sees a job. Oh, the job is not there. Let me recreate it. Okay, recreate the job. Then the job will say, not going to touch anything. Flux is managing all this stuff. Exit zero. Terraform says, yes, great. Everything is fine. No more drift, right? Because so instead of doing hacks checking from Terraform if some deployment exists, we actually have now solid logic inside the Kubernetes job in a other namespace than Flux system, Bootstrap Flux or something system. And from there we do all these checks. And if you don't care at all about anything, you can just wipe the namespace. And it's like it's fine.
Yeah, thought about this today. Let's say you're not even using Terraform to manage your clusters or whatever, right? You can still use it, like, because what else would you use, right? You would like run Helm install for Flux operator, kubectl apply for Flux instance or something, right? You can still use this module as if you were doing Helm install and kubectl apply. And you can do it like from your machine without state. You like if that's enough for you, like you're just using a very advanced way to bootstrap Flux and Flux operator without necessarily using Terraform for what the things you do. So I thought about this today because okay, we're tackling here Terraform users, right? Like people who are doing their stuff with Terraform. What about the people who are not using Terraform? Like I concluded that you can use Terraform just for this module and forget it. Like it's so good that it's worth it.
Yeah, I mean, there is also Flux operator installed, which does all the
Yeah,
things the same way,
yeah, yeah, yeah.
right? So if you don't want to write some bash scripts on top of Helm install or all the stuff, you can do Flux operator install, and it has all the flags that you can think of. You can set anything there and get everything running with no Helm, right? Because Flux operator install, it will never create anything Helm. It creates everything in terms of the Flux instance, the Flux operator upgrading itself is through a customization in our upstream OCI repo. So if you're not into Helm territory, like Flux operator install is the option where it's pure like manifest with customizations and that's it. So
Right.
I'm pretty happy now that we have like a very similar solution for Terraform where it's the burden is no longer on you to manage all this state and do all sorts of crazy tricks inside Terraform. You use it like normal Terraform, and we took over all the
Yeah. Yeah, we shoved all the shit
uh
into under the carpet and put up make a nice makeup, basically.
yeah.
Yeah. Yeah.
Yeah, anyway. Yeah,
But
so
it's
Kingdom,
solid. It's solid. The internals are ugly, but it's very solid.
we are going to do a 0.10 release of this new module, and Mateus will ping you to give it a try and migrate to it and tell us how it is. I think it's definitely way better than all the other hacks we've been telling people to do until now. We now own all the hacks. It's on us. It's in a container. We have tons of end-to-end tests and we run it everywhere. So, but in the end, it's us who owns all the lifecycle management, and we don't put it anymore on users to do all sorts of tricks in their Terraform scripts. We just use the module. It's purely declarative. It works with plan mode. It will never do a drift. It does not connect to the cluster when you do planning. It will just tell you what will happen. So I think we are also this solves what the Flux TF provider never could. Like for TF provider to run a plan, you need access to the Git repo with the secrets, the right secrets in place. You need access to the cluster with all the stuff in place, right? So you like if you are not in this environment where you have access to everything as cluster admin, you can't do a plan, which was really, really tough. So yeah, we
Yeah.
are the moment we have 0.10 out, we are going to ask you to give it a try and give us a honest feedback about it. And
Yeah.
we want to promote this as we are not going to archive or anything like that, the TF provider, but if this proves to work and it's native Terraform, we should try and promote it to people that are asking for new features in Flux TF provider. We should say, hey, can you please try this module? It should solve any kind of issues you have. You can run prerequisites before Flux. You can offload the management correctly
Yeah.
without having to do any tricks and so on.
I,
So
I
it's
have I just managed to make an end-to-end test here in the repo that bootstraps Flux in a cluster without CNI with Cilian. So deploys Cilian, it deploys Spire, and then it bootstraps Flux using the Spire CSI driver. All of that in one end-to-end test. It works.
cool.
And there's one thing, like just to show how solid this is, that because initially what we were doing is create if not exists, right? Like if there's no Helm release for Flux Operator, install. But that's not enough. Like especially for example in Flux instance. In Flux instance, if you do like apply if it doesn't exist, that's not enough because imagine you make a typo in let's say you have your sync, your Flux instance sync is an OCI repo with cosine, and you made a typo in the cosine subject. That's horrible because you like the bootstrap fails. You have to touch the cluster, right? And uh no, we fixed it by looking into the labels added by Flux to check if the resource is adopted already or not. So I I why did we do that? Because I actually ran into this problem. Like I was testing the module with our clusters and I was like I hit this problem. And in order not to have to touch the cluster and just run like my CI Terraform apply again, we had to do this. So we look at the labels. We look at the Flux since if it exists, we look at the labels and see if Flux already adopted it. If it didn't, then we reconcile. We apply the fix.
Reapply. Yeah, we reapply basically because we think, okay, something went terribly wrong if we couldn't offload the management to Flux. So we try again, right? And that
Yeah.
should cover like all the crazy situations where, I don't know, maybe you don't have nodes to run Flux on, or something. So many bad things can happen right after you create a cluster, right? The CNI could be broken, maybe you didn't allocate enough IPs, or there are so many things that can happen there, and you should be able to correct those by rerunning the Terraform apply, right? That's the whole
Yeah,
idea,
without
like,
touching the cluster. Yeah.
yeah, without having to go there, kubectl delete or whatever stuff, you should be able to reapply with Terraform and fix the stuff that's broken in the first iteration. So yeah. Um, Also, you can run Terraform apply in a loop correctly, and nothing will happen. Um, for example, Kindle said, "Oh, we have other things besides Flux that needs two applies." Well, the module should be smart enough. If you apply twice, it shouldn't cause any harm. If the first one actually worked and it offloaded everything to Flux and everything is fine, the second time you apply it, it should be no
No
op.
up. Yeah.
And whatever, for whatever reason you need to run it again, we shouldn't care, because now the job will say everything is fine with my part, exit zero.
Yeah.
Terraform says yes, the Flux module is fine, move to whatever else you have in there. I don't know. But there are so many things that people have to stitch to the cluster with Terraform for everything to be ready. So yeah.
We
Um,
need we need external secrets because we're still not on Gitless GitOps, so we need to be able to pull in a bootstrap secret before Flux is ready.
We have
cool.
like so the module has two main fields, GitOps resources and managed resources. GitOps resources is everything that you can obviously guess has to be reconciled by Flux. For example, the Flux instance, the Flux operator, and prerequisites, right? Like you need a node pool in the cluster, you need Spire in the cluster, you need Cilium, whatever, those are resources that you ideally want to manage via GitOps. So all of this goes into GitOps resources, and you have also managed resources. Which are these managed resources? Just a few. You can't go wild on these field. It's basically secrets and a runtime info config map. So you can to solve your problem with Bootstrap secrets, we got it. Like there's this field managed resources dot secrets underscore YAML. So you can use this Terraform module to manage these secrets. If you're able to inject them into Terraform, then this module can literally reconcile these secrets for you. Um, and it's literally designed to cover use cases where like you don't want to keep this secret in two places. For example, in SOPs, right? Like I cannot. Oh, okay, there's this Bootstrap module you have to run SOPs to decrypt the secret from somewhere and shove it into the model. No, we're not gonna. That's no way, right? Like basically, you can pass secrets to the module, and it will reconcile them for you.
Yeah, in
Yeah, no,
Kindle's
we're
case, they don't want to pass the secret, right? They
we're
have
just
the
using
secret
external
somewhere.
secret. Yeah, so that we
Yeah.
we use an OIDC role to pull the secret into the
Yeah.
cluster, and the roles are assigned to the cluster when the cluster is created. So um,
Yeah, in your case, you'll use the prerequisites. In there, you'll have the chart for external secret.
Mm.
We are going to install external secret before Flux from the module. Then you'll have another prerequisite, which is the custom resource with the external secret custom resource that pulls the Git secret in Flux system namespace, and then you'll go to deploy the Flux instance, and the Flux instance will find the secret already there, right?
Yeah, that's one way to do it. Like the other field I was talking about can also do these sorts of things. You can use Terraform to pull secrets from secrets. Like, are you using AWS Secrets Manager with external secrets?
Yep.
So yeah, like in Terraform, you could
Man,
read.
I need to go. I'm late to another meeting. Thank you.
Cool. See
Bye.
you. So yeah, like you can. Well, do you want to stop the recording and we can talk about this?
Yeah, why don't we? That was good. We don't have to talk about the details of my work on.
Yeah.
Thanks everyone for joining us.